So these are not difficult problems, right? What do we call this? I mean, everybody knows we do this. Well, what I'm doing right now is I'm multiplying each one of these terms by the one term, the single. It's called a monomial, that single term out front. So when I multiply in here, that's called, I heard it, distributing. Okay, so that's called distributing. Now, when we do this type of multiplication, does it have a name?
FOIL.
Okay, so you may have heard it described as FOIL, but that's just a quick way to remember that only works if you have two binomials multiplied together. It would be much better if you thought of this as polynomial multiplication, or we're just distributing two terms at the same time. So we're going to take this one, the x gets its turn being multiplied by each one of those, and then the 5 gets its turn being multiplied with each one of those. So we can call this polynomial multiplication. I kind of like to still think of it as distributing it, except for this time we're just distributing two terms in there except for one instead of one. So this is going to be x squared when I multiply x by x, minus 4x when I multiply x by negative 4. Then it's the 5's turn. So we're going to do positive 5 times the x, positive 5x, positive 5 times the negative 4, that's going to be negative 20. And then at this point we of course collect any like terms so we can simplify. So I get x squared plus x minus 20, and that right there is the answer for that multiplication problem. Any questions there? Okay, so I think I've mentioned this before, but most of what we learn in math is we learn how to do something and then we learn how to undo it. So if you think back to the very first thing you probably learned how to do as far as arithmetic goes in elementary school, you learned how to add things together. And then what did you learn second? You learned how to subtract. Addition and subtraction, those are inverses of each other. So adding 5 is the opposite of subtracting 5. Subtracting 72 is the opposite of adding 72. And we use this idea of inverses all the time. It's really good to be able to do something and then undo it. Okay? So you also learned how to square, take square roots and stuff like that. So we usually learn the easy part first. Okay, that's doing it one way. So you learn how to add. And then you learn how to undo adding, that's subtracting. That's generally a little bit harder. By the way, what's the opposite of multiplication? Division. Okay, division will undo multiplication. Those again are inverses. Okay, so if you think about how we multiply these polynomials together, when we distribute, we multiply in. It's like multiplying this 5 by each one of those terms. Well, what's the opposite of multiplying in? Okay, the opposite of multiplying is divide, and the opposite of in is out. So the inverse, the inverse of distributing or multiplying in is we're going to be dividing out. Okay, that's what factoring is, when we divide out. Okay? And a lot of times it's really useful to be able to write a polynomial as a fact in its factored form. So instead of writing a big long list of add this term, subtract this term, add this term, subtract this term, we write it as a single multiplication problem. So here are 3 rules for factoring. We're going to go over a bunch of them, but these are the only rules that we need to worry about right now. The first rule in factoring, and you're going to hear me say this about 1,000,000 times. I'll say, what's the first rule of factoring? And you're going to say, take out the greatest common factor. Now, I add to that along with its leading sign. So if you're taking out an x squared and the first term happens to be negative, take out a negative x squared. So we always take out the leading sign. Okay? If there are more than 3 terms, we're going to group them to find a GCF or to make a GCF, a greatest common factor. And then the last rule is, and this is going to be on the end of every one of our lists, you always want to make sure that you factor completely. Don't factor short. Don't stop short when you could have factored a little bit further. And then always include all of the factors in the final answer. For some reason, people tend to forget a greatest common factor and don't write it in the end. So, it says write an equivalent expression by factoring out the greatest common factor. So, what do I have in common with an 8y squared and a 20? I have a 4. What else? I could have done a 2. So, I could take out a 2. I could take out a 4. I want the greatest common factor, so we're going to take out a 4. So here's how we factor it out. I take out the greatest common factor, and then I start a set of parentheses. And then remember, this is the opposite of multiplying in, so I'm going to divide out. So what's left of an 8y squared when I divide out a 4? 2y squared. And what's left? Okay, plus a 5. Thank you. Now, the cool thing about this, in a couple of weeks we're going to have a test, and it's going to involve a bunch of factoring. That's most of the stuff that we're covering in Chapter 5. You don't have to walk out of the test and say, gosh, I hope I got that factoring problem right. How could you check to see that we did this right? Yeah, do the opposite. We're going to distribute in. We're going to multiply this out. So this would be 8y squared. This would be plus 20. We got it right. No questions asked. Good? Okay, so let's take a look at the next one. What's the greatest common factor? What is the biggest number and variable, all that sort of stuff? What's the biggest factor that I can take out of 6t squared minus 12t? 66. Okay, biggest number I can take out is a 6. Why can't I take out a t squared? Because this one doesn't have a t squared. I want to take out the largest number, and I want to take the most number of the variable. So in this case, I can take out a 6t. What's left of 6t squared when I take out a 6t? Just a t. I took out the 6. I took out one of the t's. There's a t left. What's left of 12t when I take out a 6t? Okay, please make sure that it's a minus 2. I took a positive 6t out of a negative 12t, so there'd be a negative 2 left. And again, I could check that if I wanted to. Now, just a quick word. When you do this on the test, there's not going to be an answer space for these. And sometimes it takes a couple of steps to get the right answer. So I don't want to be hunting around on the test to find, gosh, did they mean this was the answer? How about this? So please make sure you circle your answer so it's clear what you want me to grade. Any questions about that? Okay, 3 terms here. What can I take out? I can take out a 3. Can I take out an x? I can't, because this one doesn't have an x. So I'm left with a 3x. I'm left with a minus x. Whoops, that should be squared, thanks. And what happens when I take a 3 out of a positive 3? I'm left with a 1. Now, sometimes people do this wrong. Everybody watch, please. They say, hey, I took out the 3, there's nothing left, and they stop right there. How can you know for a fact that that is the wrong answer? McKay?
If you plug it back in, you won't have the plus 3 on the end.
Okay, by plug it back in, he means distribute through. So there's our 9x squared. There's our minus 3x, but there's nothing there to represent it. Okay, so there'd only be 2 terms in what we get when we multiply those out. So if there are 3 terms here and you factor something out, there better be 3 terms in here. Divide a positive 3 by a positive 3, you get a positive 1, and that right there is the answer. Okay, are there any questions? That is the basic idea with a few exceptions here. They do get slightly more difficult. Let's take a look at this. We've got 3 terms. We always want to start by factoring out the greatest common factor. It's always going to make our work easier. So if we take a look at this, let's see. What's the largest number I can take out of 16, 40, and 24? 8 is, not 4, 8. So we're going to take out an 8. What's the most number of t's that I can take out? A 1. And which one of these 3 terms limits the number of t's that I can take out? The very last one, because it only has 1. So I'm going to take out an 8t. I'm left with a 2t to the 7th. I'm left with a positive 5t to the 5th. And I'm left with a, first of all, it's going to be negative, right? Because I'm taking a positive, negative divided by a positive. That's going to be a 3, and I took out the t, so that's all that I've got there. Any questions? Largest number I can take out? I can take a 15 out of the first 2, but I can't take a 15 out of here, so I'm limited to taking out a 5. How many m's? 3 m's, so m cubed. How many n's? Only 1. You're all just working so furiously. Check with your neighbor, see if you got it right. I'll see if I can do it up here. Did I get it right? Ooh, yeah. Thankfully. Okay, let's take a look at the next couple. These aren't too bad, but they do illustrate some really important points that are going to be really useful in the next couple sections. I only have two terms. They clearly have something in common. What do they have in common?
Negative 5.
Okay, glad you said it correctly. They have a negative 5 in common. Now, even if that were a positive 35, I would still take out a negative 5 because we want that leading sign to be positive. So if I take out a negative 5, I'm left with a positive x and a positive 7. The nice thing about this is I've got one negative out front and the two things inside are positive. Everybody good with that? Okay. There's the answer on that one. And I've got a star by this one. I think I've mentioned this before, but if not, very often either the problem will come up this way or the author of the textbook will say, hey, we would just want to make sure they're paying attention. What's wrong with this? What's unusual about this? John?
The one that has a T after it is second.
Okay, it's written in what we call ascending order rather than descending order. So I would always rewrite those. Now we need to be careful. This is a positive 7 right here. So if you're going to rewrite this, the signs go with the terms. So this is a negative 35t plus a 7. Now what do they have in common? Okay, they definitely have a 7 in common, but remember, I want to take out the leading sign. I want that term in the beginning of this factor to be positive. So I'm going to take out a negative 7. That would make this a positive 5t. We kind of like that. And what do I get here? What if I take a negative 7 out of a positive 7? What do I get? I get a minus 1. Okay? Again, that 1 has to be there. It's like a placeholder. And again, you could make sure that you got this right by distributing through. If I multiply negative 7 times positive 5t, I get a negative 35t. And if I take negative 7 and multiply it by negative 1, I end up with positive 7. Okay? Any questions? Sure? Okay, we're cruising right along. I've got a question for you then. The question is this. Don't say anything out loud. How many terms do I have here? Don't say anything out loud. Just get a number in your head. How many terms are written here? Okay, now raise your hand. How many say 1? How many say 2? How many say 3? How many say 4? 5? 6? Okay. Anybody want to guess? Say it out loud rather than just raising their hand.
2 or 4.
Okay, the answer is 2. There are only 2 terms there. Okay, remember, terms are separated by pluses and minuses that are not in parentheses. So this is one entire term, and this is one entire term. Let me just illustrate. If I wrote 4y minus 3x, everybody here would say this is 2 terms. This has exactly the same structure. Something times something else, minus something times something else. Something times a y minus something times an x. There's only 2 terms here, and there's only 2 terms here. So, on this problem, there wouldn't be anything in common. Is everybody listening? This problem isn't on your paper. These don't have anything in common, but I could still factor something out. In fact, if I say you have to take something out, what does every single term always have in common? Yeah. They could always have a 1 or a negative 1. Okay, so just keep that in mind. That might come up again. So let's do this problem right here. Now that we recognize that there are only 2 terms, do they have a common factor? Do they have anything in common? Careful how you say it. They both have, I think I hear some people saying it, they both have a t minus 3. So if we're going to factor that out, you do this the same way. I'm going to take out a t minus 3, and then I start a set of parentheses. What's left of this first term when I take out a t minus 3? An r. What's left of the second term when I take out a t minus 3? A negative s. And that right there is the answer. It wouldn't be a positive what? S? No, because we took out just the t minus 3. What's left is that minus s. We didn't take out a negative, otherwise it would have been. Why didn't we take out a negative? Say that again, Chrissy? The leading sign wasn't negative, so we went ahead and took out a positive. Everybody good there? Okay, I'm going to ask this again. Don't say anything out loud, and I'm hoping you can answer this in unison. Don't say anything out loud. How many terms? I'll say it again, then answer out loud. How many terms? 2. Thank you very much. There are only 2 terms. Do they have anything in common? They do. They both have an a plus 5. So I write down the a plus 5. I put that in parentheses because they're together, and then I start a set of parentheses, and I'm going to write down what's left. What's left of the first one when I take out an a plus 5? A minus 2. Now, if you want, you can put that in parentheses. Okay. What's left of the second term when I take out the a plus 5? Okay. A plus 1. Okay, now, this is not the end of the problem. Everybody watch, please. Not the end of the problem, because I can actually rewrite this. This is a minus 2 plus a plus 1. So if I put those together, I have 2 a's, and I have a minus 2 plus a 1, so that's going to be a minus 1. And don't forget, we took out the a plus 5, so this right here would be the answer. See why I want you to circle it? Okay, are there any questions? Okay. Then what's the first rule in factoring? Seriously? Take out the greatest common factor. Thank you. You just didn't know I wanted you to answer out loud, right?
Yes.
Okay, the first rule in factoring is to take out the greatest common factor. Okay? There is almost never a situation where that's not going to make the problem easier. So we want to take out the greatest common factor. So let's look through here. We got a bunch of letters floating around here. We want to take out the greatest common factor. So, do I have anything in common with all of them? I have A's in the first 2, B's in the second 2. I have C's in the first and third, and I have D's in the second and fourth. But do I have anything that's common to all of them? No. Okay, so we could take out a 1. Okay. All right, very good. Got me on that one. So, if there's more than 3 terms, what we do is we try and group them so we might be able to take out a greatest common factor. So this is called factoring by grouping, and we do this if there are 4 or more terms. So you'll notice that we've got 4 terms here, and these are arranged really nicely. So we look through here and we think, you know what? Well, gosh, I can't take an A out of everything, but I can take an A out of the first 2. So don't write anything down yet. I can take an A out of the first 2, and then think for just a second. I'd have a C left and a D left. Now let's take a look at the second 2. Can I take anything out of these 2? I can take out a B, and I'd be left with a C and a D. Well, that sounded really a lot like what was left from the first one. So let's do this. I'm going to group these 2 together, then I'm going to group these 2 together. Whoops. Okay, good, we're sticking around here. Okay, so what can I take out of the first 2? I'm looking at just this group right here. I can take out an A. If I take out an A, I'm left with a C plus a D. Okay, now, let's focus our attention on just the second 2. What can I take out of these 2? I can take out a B. Now, what kind of B? Okay, everybody watch, please, because nearly everyone writes this down wrong. What are we taking out? A positive B. So please write down plus B. Then write down what's left. What's left is a C plus a D. Now, everybody watch, please. This is the right way to write it down. If I didn't write that sign there, this is the wrong way to write it down. Now, I realize there's enough space in here, and you know what you're doing, and most of us know what we're doing. But if you came back and looked at this work, this means A times this times B times this. It's one big long multiplication problem. There's only one term there. So that sign is really important, so please make sure you write it. Get in the habit of, when you do grouping, write down the sign that you're taking out. Got that? Okay, now, I've gone from 4 terms to how many terms? 2 terms. Do they have anything in common? Okay. So I'm going to take out the C plus the D, and I'm going to write down what's left. Start a set of parentheses. What's left of this first term? An A. And what's left of the second term? Positive B. And that right there is the answer. Now, does it matter? Everybody watch, please. Does it matter if I write A plus B times C plus D or C plus D times B plus A? Does that make a difference? It does not. Can somebody tell me why it doesn't make a difference? Why can I change the order? This has a name, yes.
It's multiplication, so it's interchangeable.
It's multiplication, so it's interchangeable. The word for that is, you know it, it's just at the tip of your tongue. It's called the commutative property. Okay? Commute, you go from one place to the other, so we can take things and move them around in a multiplication problem and it doesn't change the answer. 4 times 5 is 20. 5 times 4 is 20. Okay? All right, so let's take a look at this next one. This one is different. If you've been working ahead, has anybody been able to get this one? Okay, take a good look here. This is why you want to think about it first. Do these have anything in common? These first two. They've got an x. If I were to take out an x, listen carefully, I'd be left with an x and a 12y. Well, that's not so bad. Maybe that works. Do these have anything in common? They don't even have anything in common, other than a 1. If I took out a 1, I'd be left with 4x cubed y plus 3 and that sort of thing. Okay? So that would just turn into a mess. So, a couple clues on how we'd rewrite this. Do we have more x's or more y's? More x's. So let's say that they're kind of more important. I'm going to focus on the x's for just a second. And we normally write x's in what order? What's it called again? Where they go down? It's called descending order. So this has the most, next most, then this one. So I'm going to write it in this order. I'm going to write this down as, let's see, minus 4x cubed y plus x squared minus 12xy, and then at the end I've got this plus 3 floating around. Now, you certainly can't take anything out of all of them, but if there are 4 or more terms, we're going to group them. Is everybody listening? Normally, we group the first two together and then the last two together. So I'm going to cover up these guys right here, and we're just going to focus on this right here. Do they have anything in common? They have an x squared, right? So I'm going to take out, somebody said it, Ari, what did you say? We're going to take out a negative x squared. If I take out a negative x squared, I'm left with, the negative's gone, I'm left with a 4, and I have an x and a y, right? If I take out an x squared, let's see, I took out a negative x squared, so I'd be left with a negative 1, right? Everybody okay with that? Okay, so let me bring these back. I'm going to cover this stuff up. Let's look at these right here. Do they have anything that I can take out? Okay, what kind of 3? We're going to take out a negative 3. Make sure you write the sign, and then we're going to write down what's left. What's left is, let's see, I took out the negative. I took a 3 out, so that's a 4. I didn't take out any variables, so I've got an x and a y. And I took a negative 3 out of a positive 3. What am I left with? A negative 1, right? Okay, now I'm going to bring this back. I've gone from 4 terms to 2 terms, and do they have anything in common? They do. So they both have a 4xy minus 1, and then I'm left with a minus x squared from the first one and a minus 3 from the second one. Okay, are there any questions there? Yeah.
So even if down the very last thing, if the leading coefficient has a negative, do you just leave it?
Okay, I'm going to point that out right now. I would accept this as an answer on a problem like this, but it would be slightly better if we said, hey, you know what? I can factor this completely. I can take something else here. What do these both have? They both have a negative 1. So I could take the negative out, and then I'm left with 4xy minus 1, and I'm left with x squared plus 3. This would be slightly better, only because it looks better, okay? Because I've got this, they're both positive, a little easier to work with. I'm probably less prone to make mistakes with that. Yeah?
So on Math Excel, if we get a problem like that, do you want us to factor out the negative at the very end?
I would. There's nothing mathematically wrong with this, and it's not that this is a lot better. It's just that we factored it completely. Okay, remember that's the last rule in factoring. We want to factor completely if there's anything that we can take out there. Yeah?
Would the 1 be a positive if you took out the negative?
With this one?
Yeah.
No, because I took it out of this one. So think of it being written out here in parentheses. So all I did is I slid this negative out front. Okay, I didn't take it out of here. I took it out of the other factor. Yes?
So if we try to distribute it all back, it would work out evenly.
You bet. Yep, it would work out to be exactly what we started with. All 4 of those terms. Okay? This is a tough one. This is a tough one. It's a complicated problem. Lots of stuff to take out, lots of signs to be concerned with, stuff like that. Okay, any questions? Sure? Okay. The interesting thing is there's usually more than one way to factor. There's more than one way to write this. Okay, so you could arrive at slightly different answers. Okay, we're going to do one problem on the back side, but I do want to point out, just to get ready for 5.4, this is pretty easy. It's like the stuff that we did at the beginning. If you just multiply those 2 binomials together. If you want to think of it as FOIL, that's fine. I'd prefer you think of it as polynomial multiplication or just distributing in 2 terms rather than just 1. Okay? And then you can do that on your own. I want you to take a look at the back side, problem number 57. Okay, all they're doing here is just giving you some problems, kind of making them real life, okay, and showing that you can actually use factoring in problems. So it says a baseball is popped up with an upward velocity of 72 feet per second. Its height in feet after t seconds is given by this. Okay, it's a story problem. A lot of people, their brain just absolutely freezes once you start reading sentences in math. We freak out about this and all that sort of stuff, but here's the idea. This is a function. H of t. H stands for height. What's t? Like in most problems, it's time. So you plug in a time and it will tell you the height of the ball in this particular case. That's not that bad, is it? Part A. Find an equivalent expression for h of t by factoring out a common factor with a negative coefficient. Now, why would they want us to take out a negative coefficient? Why would they want us to take out a negative? Make it look neater, and it starts with a negative, right? It's kind of just restating the rules that we were talking about earlier. So I'm going to take h of t, and I'm going to factor out, well, let's see. I'm just focusing on these 2 terms right here. What can I take out of a negative 16t squared and a 72t? Tyler?
Negative 16t.
Okay, negative. Can I take out a 16? Gosh, 72 looks like you ought to be able to. Let's check and see. 72 divided by 16 goes in there 4 with a remainder of 8. Okay? So we can't take out a 16. It would be nice if we could take out that big a number. 8. 8 is the biggest thing you can take out. So we're going to take out a negative 8 as far as the number and the sign go. What about the variable? I can take out a t. So if I take out a negative, that's gone. Take out an 8 from a 16, I'm left with, remember, we're dividing out, we're not subtracting, so it's a 2. It's not an 8 left. And a t. And what am I left with here? A negative, because I divided by a negative. 72 divided by 8 is 9, and I took out the t, so there is the answer to part A. Okay, and then it says this. Perform a partial check. So we want to check and make sure if we think we've got the right answer. By evaluating both expressions for h of t at t equals 1. So I've got 2 expressions. I have h of t equals negative 16t squared plus 72 times t. And we're saying that the 2 of these are equal. They're interchangeable. They're just different forms of the same thing. And it wants us to check that by, what does h of 1 mean? plug 1 wherever there's a t. So this would be negative 8 times 1, 2 times 1, minus 9. So that's going to be negative 8. Let's see, that's going to be 2 minus 9, so that's going to be negative 9. So my answer is 72. Let's check over here. What's h of 1 here? Yeah. Oh, what did I do? Oh, 7, thanks. 56? And we all feel better.
Yeah.
Okay. But if I made that type of mistake on a test and I checked it over here, I mean, this one's a little easier, right? This is going to be, well, this is negative 16 times 1 squared plus 72 times 1. This is negative 16 plus 72. I would have gotten 56 here. And then I would have been comparing over here and said, well, hey, that's not right. And then I would have automatically double-checked my arithmetic, right? Okay. But they are the same, so there's our partial check. Any questions? That's all they're asking. Factor it and just make sure that you actually factored it right. Okay. You've got about 20 minutes right now. I will run up and check.